So it can help. So for example, 5, it wouldn't help. Okay, because, well, you can't, I mean, he's put in 2 points. You got to know how to come up with the equation of the circle. But maybe one like even 4, guess and check, or one like 2. So here, I'll show you, let's see, on your calculator. If you weren't sure how to graph it, you totally forgot, you can go to Desmos. Entering it in, hopefully you can do that. And by the way, just again, if you don't have a Desmos calculator on your phone, just go to Desmos. Search it, Google search, and hit it. It should come up. So you got to start with parentheses on this. If you don't, you'll have to kind of go back. So I'm doing number 2 there. I'm just going to put in x minus 2 squared. So then let's see if it does. Well, I got to close the parenthesis. Then I got to hit the caret and 2. So I'm not done yet. Because right now it's a parabola. So then I'm going to do, you hit, well, I think I just hit plus. Yeah, I don't know if it goes to the right. Close or open parenthesis, y plus 4, close parenthesis, caret squared, equals 36. God, look at that. It graphs it for you. So if you totally forgot how to do this and find the center and the radius, you could put this in the Desmos. Look at it. The center is right here at 2, -4. So right? Yeah. Right there, 2, -4. And then you can count to the side or up to find the radius. So pretty helpful. I will also mention for tomorrow, here, let me show you one from tomorrow, where we have to put the equation in standard form to graph it. Well, guess what? Desmos will do all of these very well for us. Now, sometimes they ask for specific parts and might not be able to do all of it, but you could just enter in the equation. All right, so Desmos can be very helpful for these. Maybe 5, maybe 6 will do that. It wouldn't. 7 it actually could. Remember when you're like, look at this. Is this on the circle, in the circle, or outside? You can just put in x squared plus y squared equals 4. X squared plus y squared equals 4. There's the circle. And then you could just put the points. You could actually plot a point on Desmos. So you could put 1 comma square root s. If you write SQRT, it'll take the square root, or you could find the square root button on the keyboard right there. So square root of 3. All right, look at that. So it verifies that that point was on the circle. Okay, so nice little feature for equations. Let me do the other one there. 2, 1. That should just verify 2, 1. That was outside the circle. So I do really like that. Helps us. Unfortunately, we don't do as much with parabolas, or it can help us with lines, graphing lines. But that's about it. We'll do more with Desmos. I want to make sure that we can at least use that a little bit moving forward. But hopefully, you guys put a circle on there, and you could see how to enter it and verify some of these. So, any thoughts on using Desmos? Help us out. It's very nice. This is the state test calculator that you can use. So, did you use it much last year?
Yeah. Well, we
There was
did
a lot of
this
tests last
activity
year.
about it where we had to put our name on it, and then that was it.
Yeah.
Well, no, we used it
Maybe it
many times.
depends. All right, so I just got one example to finish up from yesterday. So it was example 6. Let's do this one.
We made a house out of it. I'm not joking.
So it's example 6, and then I'll just work on some of the circles practice. So here's another one where you wouldn't actually be able to put this into your Desmos, but we can figure out some other parts of it here on our own. So here we go. Circle P has a radius 3 times that of circle Q. So here's what I did. I just made, here's circle Q. Here's circle P. This one just has a radius. I just wrote R. I'll put in a number soon. This one has a radius 3 times. right, so circle P, the radius is 3 times as big as circle Q. And now, the next part just says for arc lengths and sectors, area of sectors of congruent central angles. Meaning we're not comparing the arc lengths of this central angle to this one. Okay, we're comparing the same ones, like that central angle and this central angle. So we compare the same central angles and corresponding arcs. We're going to see what happens with the arc length and area of the sector. So what does it say? Compare the arc lengths and the area of the sectors for circles P and Q. So basically what I'm going to do is just find the arc length and sector area for each one. Now, on these, you could leave it as R and 3R, but a lot of times on problems like this, it's good to just choose a number. Okay. So to do, let's start. Let's do circle Q first. We'll do arc length and area of a sector. So arc length is going to be something over 360 times 2 pi r. Now here's where we just need to choose some numbers, and we'll stick with those. So what central angle do you want to use? $60? 60 is probably good, or 90. So we're using the same one over here. Okay, we're going to compare the same central angles. What radius do you want to use here? 3. So then over here it's 3 times, it's triple, so it's 9. Now all we're going to do is find the arc length, arc length and area of a sector, and we'll see how they compare. So all we're doing, basically guys, they're similar, so all circles are similar, but we just dilated by 3, made it 3 times as big. Let's see how the arc lengths compare. Because you might say, oh, it's going to be 3 times as big. Maybe, maybe not. All right, so circle Q. Let's do arc length. It's 60 over 360 and 2 pi times 3. So this will be, I mean, we can just put it in our calculator now, or this is 1/6. 2 times 3 is going to be 6. So actually it's going to be 1 pi. If you did 60 divided by 360 times 2 times 3, you're going to get 1. That was nice, yes, good call.
Yeah, I did that all in my head beforehand.
Did you?
No, I didn't.
Let's go ahead and do circle P to compare. So circle P, we're doing arc length still. The central angle is the same, 60, and then over 360, times 2 pi, this time the radius is 9. We just needed a number to throw in there. You can pick whatever number you want. A good choice up here for 60. So 60 over 360 times 2 times 9 should be 1/6 of 18. So I think 3, right?
Yeah.
Yeah. So you do in fact note that if you make the circle 3 times as big, the arc length is also tripled.
That makes sense.
Yeah. Area? I think it's going to be the same as well.
I don't know if math's that simple.
Yeah. By the way, this is often a strategy we'll use for volume coming up. Where like, if they don't give you the numbers, just throw in some values and then compare the shapes.
That's my favorite thing to do.
Throw in numbers and compare the shapes?
No, I just use guess and check a lot when I don't
I
know the
see.
actual answer.
So sector area, let's go back to circle Q. The sector area, same formula, except at the end, it's pi r squared, so pi 3 squared, instead of 2 pi r. So this time, 60 over 360 times 3 squared. I mean, that's 9 again. So it's a 1/6 of 9. Let's do 1.5 or 3 halves. Yeah. Pi. Okay, to finish up, we'll do circle P. Same thing, except the is now 9. So 60 over 360 times 81. 9 squared.
It's like 7.74.
Hmm?
Am I done that wrong?
Yeah, I don't know.
6 divided by 360. Oh, yeah, I know. 13.5.
I also got 13.5.
13.5.
Oh, I did. Wait, hold on.
Okay. 13.5. This one might be a little. This one might be a little hard to see.
Okay, no, I did 630. That's why it was wrong.
It's not 3 times as big. Let's do 13.5.
Divided by.
Yeah, 13.5 divided by 1.5. It's 9 times as big.
Oh, because it's units. It's units squared, so of course it's gonna.
And that's pretty much it, yeah. So here, let's write it down. So arc length stayed 3 times as big when you triple the circle. Sector area, 9 times as big. And yeah, so actually, like you said, area is squared units. You can think of it like that. We basically took, our scale factor was 3. Squared it here. The scale factor, 3 times 3 was 9. And so we actually, for area, square that scale factor. It's 9 times as big. Yeah. Okay, nice. I think that's all we had to finish up on that one. So,
I feel like.
yeah.